In this example, we've got an equation where the x's and the y's are mixed together in a way that it's difficult to solve for y. So this, when we find the derivative of y, we're going to have to use implicit differentiation for this. So for part A, I'm going to find the derivative of each part. But when I find the derivative of y, I'm going to have to add a y prime to it. So derivative of x cubed is 3x squared plus derivative of y cubed is 3y squared. And I just did derivative of a y, so now it gets a y prime. Equals 6 is a constant, so that can stay in front. Or you can put the 6 with the x. I'm going to put the 6 with the x. So over here I've got a product rule. So I've got 6x, leave the first alone, then derivative of the y. Derivative of y is 1, but then we do y prime, because I just did derivative of a y. Plus, then I leave the second part alone. So now, this doesn't get a y prime because I didn't do the derivative of it. I'm just leaving it alone. Then I do derivative of 6x, which is 6. So that's my derivative, but anytime you find the derivative, you then want to solve for y prime, get y prime by itself. But I've got two of them. So what I want to do here is get the y primes on one side of the equal sign and get everything else to the other. So I'm going to subtract this 6x y prime over here, and I'm going to subtract 3x squared over there. So I've got 3y squared y prime. Then I'm subtracting this one over here because it has a y prime on it. Over here I have a 6y, and I'm subtracting 3x squared to the other side. So now I've got my y prime terms on the left, my non-y prime terms on the right. And then you want to factor out the y prime. And so that's why we wanted all of our y primes on the left, so that we could do this factoring step. Then we want to get y prime by itself, so we divide both sides by the 3y squared minus 6x. And then this is my answer, but if you notice, they all have 3 in common, so I can factor out a 3. If you take 3 out, we get 2y minus 1x squared over 1y squared minus 2x. So that's my answer to part A. Then B, they want us to find the equation of the tangent line to the folium of Descartes. This is a special equation. They've given it a name. It's the folium of Descartes. So that's not really important to this problem. But there's a graph. If you graph it, it makes a cool looking graph. And I've got that on the next slide. But at the point 3, 3, they want us to find a tangent line. And remember that derivative is slope. So I just found the slope. If I wanted the slope at 3, 3, then I need to plug 3 in for x and 3 in for y, because they gave me an x and a y. So part B, I'm starting to find the slope here. If I plug in 3 for y, and if I plug in 3 for x, I get 6 minus 9 over 9 minus 6, which is negative 3/3, which is negative 1. So that's my slope. And then the equation of the line, we do y minus y1, which is 3, equals slope, which is negative 1, x minus x1, which is 3. And we can leave it here. This one's pretty easy to solve for y, so let's go ahead and do it. It'd be negative 1x plus 3, and then I can add 3 to the other side. So that is an equation of the tangent line to that curve at the point 3, 3.